let us treat the second type of volumetric analysis, or the second type of acid-base titration, second type of titration. Now, I made mention that we have four types: acid-base, redox, precipitation, and complexitometry. So let us look at what the redox titration. Look at the redox titration. Is one of the types of acid-base what titration. So if to explain the redox titration is a titration analysis which exists between oxidizing agent and a reducing agent. That is, this kind of titration, it involves the oxidation and reduction reaction. And this, we can also say what? This is a what? A volumetric analysis method. Analysis what? Method. Or this is a what? A titration analysis method. It's the same, based on oxidation, oxidation and reduction. If you are talking of oxidation and reduction, simply means what? Electron transfer. Electron what? Electrons. Trans what? Transfer reaction. So what is the what? Redox. The redox titration is a what? Is a titration analysis that occur or evolve the what? Occur in oxidation and reduction reaction, which involve the transfer of what? Of electron. So the redox titration is a volumetric analysis method which based on oxidation and reduction reaction. What is the meaning of oxidation and reduction reaction? It involves what? Transfer of what? Of electron. Or you can also say what? In this. In what? In this what? Titration. One solution acts as an oxidizing agent. Oxidizing agent. And the other, and the what? The other acts as reducing agent. Please, before we can understand the redox reaction or redox titration very well, you need to go back to the what? Redox reaction. The that involve oxidation and reduction, and you must know how to define oxidation, how to define reduction in terms of electron transfer, in terms of oxidation number, in terms of hydrogen, and in terms of oxygen. So if you have difficulty in a redox reaction, you can check my channel. There is a video there that explains the redox reaction and how to balance the redox reaction in both acidic medium and the basic medium. Please, it will help us in this practical. So this titration, one of the what? The solution it acts as what? As an agent other as what? Reducing agent. That is, we can have like this, we can have what? Oxidizing agent react with, let me write it in full, oxidizing agent plus reducing agent. So to give us what? Products. So for any reaction that undergo the redox, comprised of what? Oxidizing agent and a reducing agent. This is the product. And the titration analysis that involve oxidizing agent and reducing agent is what we call what? Redox titration. Simple. Redox titration is a titration that involves oxidizing agent and reducing agent. Or is a titration that involves the what? Oxidation and reduction reaction. Transfer of electron. That's what we call what? Redox titration. And this redox titration can be divided into what? Into four parts. Yes. Can add it what? Into how many parts? Four types of redox titration. The first type of redox titration, we have what we call permanganate. Permanganate titration. The second one, we have what we call dichromate titration. The third one, we have iodometry titration. The fourth one, we have Iodimetry titration. So these are the four types of redox titration. So let's take it one after the what? The other. The first one is what? Permanganate. Permanganate titration. Titration. This permanganate titration, you can also call it what? Permanganometry titration. Is a kind of titration. Is a kind of what? Of redox titration in which KMnO4 is used as an oxidizing agent. This permanganate titration is a kind of what? Of titration in which what? K what? When KMnO4 is used as what? Oxidizing agent, the type of redox titration is called permanganate titration or permanganometry titration. So this one, when what? KMnO4 is used as what? As an oxidizing agent, or it acts as a strong oxidizing agent for the titration. We call it what? Permanganate titration. But whenever the what? The potassium dichromate is used as what? As strong oxidizing agent, the titration is called dichromate titration. That is, here we use what? K2Cr2O7 as what? As strong oxidizing agent. And the titration is called what? Dichromate titration. So when what? K2Cr2O7 is used as strong oxidizing agent, the titration is called dichromate titration or dichotometry titration. But whenever KMnO4 is used as what? As strong oxidizing agent. In redox titration, the type of titration is called what? Permanganate what? Titration. But here, iodometry titration. This iodometry titration is also called what? Indirect titration. Indirect what? Titration. Because the reagent used in iodometric titration is what? Is sodium thiosulfate. Sodium thio what? Sulfate is the reagent that we use in what? In redox, in the iodometric titration. This iodometric titration is a titration that exists between what? Sodium thiosulfate and indirect iodide that is produced from potassium iodide. So whenever we titrate iodide, a sodium thiosulfate with what? With iodide that is liberated from potassium iodide, and the reducing agent is called iodometry. But this we call iodometry, but the or iodimetry, this one, the iodimetry titration is a direct titration between what? The iodide gas, yeah, is served as what? As reducing agent here. Hello? The iodide serve as what? As reducing agent here. But here, the reducing agent here is not iodide, is what? Sodium thiosulfate. So that is the basic difference between what the four types. But you will understand fully difference between iodometry and what? Iodimetry titration. So back to the what? Permanganate what? Titration. The permanganate titration, this is a what? A type of redox. Type of what? Of redox titration in which KMNO4 acts as reducing, act as strong oxidizing agent. See, whenever the KMNO4 is used as strong oxidizing agent in redox titration, the kind of titration is permanganate titration. Then, what is the main function of permanganate titration? What are we use the titration for? It can be used to what? To estimate or to determine the concentration of what? Of hydrogen ion, of iodide of a ion 2 ion. Yes, let me write it down. And oxalic acid, yes, is used to what? This it is what? Used to determine the concentration of is used to determine the what? The concentration of oxalic acid per oxide, yes, is used to determine the what? The concentration of what? Of ion 2 ion, yes, oxalic acid, which is what? A2, C2, O4, and peroxide, which is what? Hydrogen peroxide. Hello? See, this permanganate titration is used to determine the unknown concentration of hydrogen ions, oxalic acid, and what? Peroxide, hydrogen peroxide. Those are the three common solution, unknown concentration of a solution that we can use what the KMNO4 to what to determine during titration. So the next thing is what is the redox or the chemical nature of what? Of KMNO4. Or we can also call it what? Chemical nature or redox reaction. A chemical what? Let me call it redox reaction. Redox reaction of what? KMNO4. Hello. For this now, we know that is what in a permanganate titration is titration between KMNO4 and ion, or between KMNO4 or an oxalic acid, or between KMNO4 and what? Peroxide. So these three solutions, they are unknown solution that we will use what? The titrant KMNO4 to determine the analyte. So what is the chemical nature of what? Of the KM what? KMNO4. See, this KMNO4 occur in what? In acidic medium. In what? In acidic what? Medium. You're supposed to understand this in redox titration. So the KMNO4 in acidic medium is reduced. Is what? Reduced from, can you see, from NO4 minus, reduced from MnO4 minus to what? To Mn2dis. If you look at this is the reaction. MnO4 minus the oxidation number for this manganate here. Oxidation number for this manganate here is what? Is +7. The oxidation state, oxidation what? Number for manganate here is what? Is plus, let me write it, is plus what? +7. So when it's reduced, it will give us what? Mn +2. So the oxidation number of what? Of manganate here is what? Is +2. So this is what? The redox reaction of permanganate is what? Is oxidized from what? From +7. It's reduced from +7 to what? +2 in acidic medium. And the second part of this is this KMNO4. K what? MnO4. The color here, from the beginning here, the color of this KMNO4 here is purple. Is what? Is purple. The color is purple. When is now is what? Why KMNO4, this is what? Is purple. Why is why N manganate 2 ion is colorless. So in redox reaction of KMNO4, if you put the KMNO4 into what? Into the burette, and the what? The ion or oxalic, any one of the analytes here, put it to the what? The pipette, and put it to the conical flask. So the color of this man is purple originally. So if you are not trying to what? The reaction is about to take place between the analyte in the conical flask and the what? The titrant in the burette, At end point or equivalent point, the purple color of the what? Of KMnO4 will change to colorless. So for this kind of titration, there's no need for us to want to use indicator. We will use because the KMnO4 is colorful itself. So when it gets to the what to the end point, it will change to the colorless. As a result of that, in this kind of titration, we commonly use what we call self-indicator. Self what? Self-indicator. Because the KMnO4 is color himself. So that's what happened here. So the chemical nature for what? For KMnO4 titration is this. This is a redox reaction, and the color change from purple to what? To colorless. And the next thing is the kind of what? Indicators use. What is indicators use here? Yes, let me put it. Indicator. What is indicator for this reaction or for this titration? What is indicator use? The indicators use is what? We call it what? Self-indicator. So the type of indicator used in the what? In the titration of KMnO4, and any one of these three is self-indicator, or in permanganate titration is self-in the what? Indicator. And what is the common redox reaction that you can use what? The KMnO4 for? Abi, what are the what? Let me say the common. The what? Common redox reaction in KMnO4 titration. What are the common reactions? See, I said it earlier. This is a very basic common reaction of what? Of KMnO4 titration. The first one is what? We can titrate KMnO4, the first one with Fe, sulfate, iron sulfate. So this iron sulfate it will serve as what? As analyte. We can also titrate what? KMnO4 with what? With oxalic what? Acid. With oxalic what? Acid. This oxalic acid is C2 is H what? H2C2O4. We can also titrate what? KMnO4 with peroxide. Per what? Oxide, which is what? Hydrogen peroxide. So these are the three analytes that we can use for the titration of what? Of permanganate. And what kind of what? Of indicator we use? The indicator used there is known as what? Self-indicator. That is all about what? Permanganate titration. The next thing is what? Let me explain the second kind of titration. So the second type of redox titration is dichromate titration. In dichromate titration, the K2Cr2O7 is used as strong oxidizing agent. Okay, that's what this a type of redox titration in which K2Cr2O7 serve as a strong oxidizing agent. Don't forget, particularly in acidic medium. So whenever the K2Cr2O7 serve as oxidizing agent in a redox titration, the kind of titration is called dichromate titration. But if I said, K what? KMnO4 titration is used to determine what? Correlation of ion, abi, or iron sulfate. Yes, it is to say what? Oxalic acid, H2C2O4. Abi now? And we also use in what? In the hydrogen peroxide. This is are the reagents we use the KMnO4 to determine their concentration in the redox titration. The function of KMnO4 titration is what to determine the concentration of all this. But what will be the what? The function of K2Cr2O7 titration in redox titration. The function of K2Cr2 what? O7 in redox titration is also used to what? To determine the concentration of what? Reducing agent. It is that one, K2Cr2O7. This one can also use to determine the concentration of what? Of ion. Concentration of what? Of ion. Can use what? Can the concentration of what? Of tin plus, and also used to determine the concentration of what? Of iodide ion. Please, these are the difference between them. So we can now say what? This dichromate solution, it is used to determine the concentration of reducing agents such as iron 2 plus, tin 2 plus, and iodide ion. What? Iodide ion. So that is what? The purpose of dichromate titration. We used to determine these three solutions. Let us look at what? The redox reaction in it. The redox reaction in what? In it. Redox reaction in K2Cr2O7. Yes, let's check it. It's also in acidic what? Medium. It's also in what? In acidic what? Medium. We can say what? In acidic medium, acidic what? Medium. K2Cr2O7, Kr O7. If I remove this K, the 2 will come here, 2 minus. So Kr2 what? 7 is reduced. Is what? Reduced to chromium. Yes. Cr3 what? Plus. Check it. This is the reaction. We have iron, 6 mole of iron react with what? Cr2O7, 2 minus, and it's what? Reduce to give us what? If I want to, let me, okay, balance it straight. Let me balance it. Plus 4 zinc hydrogen ion with 6 Fe, 2 plus chromium 3 We have 2 plus, how many do we have here? 14. We have 7 water molecule. If you have problem to how to balance this, go and check my video on the balancing of redox reaction. So what do we need here is this. The color of this chromium here is what? Is orange. The color of chromium here is what? Is orange. So, and it changed to what we call what? Green. So in acidic medium, chromium here is green orange, but chromium 3 ion is what? Is green. That is what? The redox reaction of what? This. That is, the original color for this K2Cr2 color is what? Is orange. It's orange, but at the end of the word of the titration, it will give you what? Green. So in this aspect too, we can also use what? Self in the what? Indicator. But at times, we may decide not to use self indicator. We can use what? Diphenylamine as an indicator for this reaction. So this is what? The redox reaction. Then the next thing is what? Indicator use. Indicator. Indicator use in dichromate titration. What are the kind of indicator we use in what? In this titration. So I said that what? If you like, we can use what? Self in the what? Indicator. Because the original color for this KMNO4 is what? K2CrO7 is orange, and it can change to the what? To the green at the end of the what? Of titration. So because of that, this is what says what? Indicator. The second one, we can also use what? Diphenylamine. If we use what? Diphenylamine as what? As an indicator at the beginning of the what? Of the titration, it will give us what? Colorless. To give us what? Color what? Colorless, and change to the violet at end point. So when we use diphenylamine as indicator in the redox titration of that involve K2Cr2O7, and we use diphenylamine as well as an indicator from the beginning of the what? Of the titration in the conical flask, we have colorless. As time goes on, it will now change to the violet color at the end point. So that you stop your what? Your titration. We can also have what? N-phenylamine. We can also use what? N what? N-phenylamine what? Amine as an what? Indicator. So if we use N-phenylamine as an indicator, from the beginning of the what? Of the titration, we have a pale green. Pale what? Green. And at the end of the what? Of the reaction, it will give us what? Violet at the end point. Please note this. In K2Cr2O7 titration with tin ions and diphenylamine is used as indicator. What is the color at the end point? Violet. But if N-phenylamine is used as what? As indicator from the beginning of the what? Of the titration, it will give us pale green. At the end point, we have a violet color. But if you decide not to use any indicator, the original color for the K2Cr2O7 is orange, At the end of the what? Of the titration endpoint, it will give us what? Green. So if the self indicator is used, we have what? Orange to what? To green. So that is what the types of indicators used in what? In dichromate titration. And the next one is iodometric titration or iodometric titration. Let's treat iodometric titration. So the next, which is what? Iodometric titration. Iodometry titration. So, no, I'm having iodometry before iodometry. This place is going to be O. Yes, after iodometry, we go to the what? Iodimetry. So if you are talking about iodometry, what is iodometric titration? The iodometric titration, this is the what? A types of redox titration that involve the indirect determination, involve the indirect determination of oxidizing agents. Indirect what? Determination of what? Of oxidizing agent through the liberation and titration of iodide. Through the liberation and titration of iodide. So this kind of titration is called indirect what? Titration. Because the what? Iodide used here is first of all obtained from potassium iodide through the copper or iron or peroxide or chlorine, any one of the what of the analytes. So I will continue. Yeah. Let me establish one fact here too. I said the function of this permanganate is to estimate this for this KMNO4 to estimate what? Iron or tin or iodide. What is the function of what? Iodometric titration. The iodometric titration, Iodometric titration can also, like this, iodometric titration can also be used to what? To determine the concentration of the what? Of copper, of iron, of chlorine, and of peroxide. We can use iodometric titration to determine the concentration of copper, iron, chlorine, and what? And peroxide. So I can say what? It is used to or for estimation or estimating, is used for estimating substance like copper, iron, chlorine, and what? Peroxide. And let me add one thing to this iodometric titration. In iodometry titration, iodide, I what? Dye is liberated. The iodide is what? Is liberated and then titrates with liberated and titrate with standard solution of sodium thiosulfate. Sodium thiosulfate, which is what? Na2S2O3. The iodide that is liberated from the potassium iodide, which serve as what? The source of iodide here, is then what? Titrated with what? With standard solution of sodium thiosulfate. That is the reaction that takes place in what? In iodometric titration. Let us look at the principle of iodometric titration and the reagent and the indicator we use in iodometric titration. What is the principle of iodometric what? Titration. Principle of iodometry titration. One, an oxidizing agent. An oxidizing agent the oxidizing agent for this titration with these three things I mentioned here. It may be copper ion. Please note that. It may be what? Chlorine molecule. Or it may be what? Oxidized iodide. It may be what? Oxidized what? Iodide. Oxidized iodide is iodide minus to form iodide gas, which is what? I2 or iodide molecule. Which is what? I2. Look at the reaction for that. If we have a copper 2 plus, now react with what? The iodide salt. But this iodide salt is majorly what? Potassium. And when this copper reacts with what? With this iodide salt, it will now give us what? Copper iodide plus 2 plus iodide molecule. So to balance this thing up, let me put 4 here, then 2 here, 2 here. Iodide is balanced. Copper, yes. So this is the iodide that is what? That is liberated. So I said what? So this copper oxidizing agent copper is what? Is the oxidizing agent to form iodide this. This is the gas. And the next thing that is what we need here is the iodide that is liberated here. The liberated iodide, which is A2, is then titrate with sodium thiosulfate is then titrate with sodium thiosulfate. So the next thing that we do now is what? We will now take this iodide and titrate it with what? With sodium thiosulfate. By doing that, we have what? Iodide and what? Iodide 2 react with what? Sodium thiosulfate. This one will be in ion 2 sodium and thiosulfate what? Ion minus 2. Yeah? It will now give us what? It will now give us 2 iodide ion plus S4O6 2 minus. This is what we call what? A titration step. So this is what? The principle and the redox reaction that occur in iodometry. The iodide is titrated. You know, I said it here before, that sodium sulfate is what is titrated with what? With iodide. Here. But the next thing is what? Let's look at the reagent of this iodometry. What? Reagents used in iodometry titration. What are the reagents used? The first reagent used is what? We have potassium iodide, which is served as what? Is a source of iodide. This iodide we have here is the source is potassium what? Iodide, and the second one is sodium thiosulfate is served as standard titrant. And the next one, what kind of indicator we use here? We use starch indicator. And the starch indicator form a blue black complex at the end point. So these are the 3 basic reagents we use in iodometry. What kind of indicator used in iodometry titration is starch indicator. So the last aspect of type of redox titration is iodimetric titration. So the last aspect of redox titration is iodometry. Yeah? Iodimetry titration. So iodometric titration is a redox titration in which a free hydrogen is used as titrant to determine the concentration of reducing agent in a solution. So this is a what? A redox titration in which free iodide is used as titrant. As what? Titrant to determine concentration of reducing agent in a solution. in this method of titration, direct hydrogen or direct what? It involves the titration of direct what? Iodide against reducing agents. So the iodide come directly, or it involves what? Direct iodide. It involves direct titration between iodide and reducing agents. There is no intermediate in Iodometry titration. What is the principle of Iodometry titration? Principle of Iodometry titration. Are we there? Here, iodide here acts as oxidizing agent. Here, as iodide acts as what? Oxidizing agent. But in iodometry, copper ions, it acts as what? Oxidizing agent. So iodide acts as what? Oxidizing agent. And here, the reducing agent in a solution, which is what? Sodium thiosulfate, reduce iodide, free iodide molecule to iodide what? Ion. You cannot say what? Here, the reducing agent, the reducing what? Agent in what? In solution. In solution, what is it? It's sodium thiosulfate, abi, reduce what? Iodide. It reduce iodide, which is what? I2 to iodide ion, which is what? I minus. So, but we have a general reaction for that. Yes, you can say what? Iodide, general what? Let me say general reaction for this principle of iodimetry. General reaction for it. The reaction will back up this statement. So I said we have what? Iodide 2. Abi, this iodide 2 plus analyte plus what? Light, unknown concentration. It will now give us what? Plus unknown concentration with analyte 2 iodide what? Minus, which is what? Iodide ion that I said here, abi, plus oxidized products. Oxidized what? Products. This oxygen iodide we have here is an oxidizing. The iodide we have here is an oxidizing what? Agent. The is oxidizing agent. Analyte we have here is what? Reducing a what? Agent. Iodide reacts with reducing agent. This iodide molecule will form iodide ions and what? Oxidizing products. Take for example here now. Let's take this as a case of study. If we have what? Reaction of iodide 2 plus react with what? 2 molecule of what? Sodium thiosulfate, abi, yes, which is S2O3 2 minus thiosulfate. Yes, it will now give us what? This is what? 2 hydrogen iodide plus S sulfur 4 plus O62 minus. This is what will give us here. And don't forget, this is what? Oxidizing what? Agent This is what reducing agent. This is iodine air what form. This is reducing product form. When the what the sodium sulfate is served as analyte and is titrated with what iodine directly. This is iodometric. But what kind of indicator used in iodometry? We can also use starch as indicator. In the indicator use. Yeah, we use starch as an indicator, and which is from blue, black, complex at end points. So that is all about uh, that is all about the four types of redox titration. But let me summarize everything here before I will solve four questions on this. We now stop for for today. Let me summarize the table. Before I will summarize the three type of redox, let me just give you this difference between iodometric and iodometry. Picture between iodometry and we have iodometry titration and we have iodometry titration. So if you look at the difference here now, the type, let's look at what types of the titration that occur here. The iodometry is direct titration. Is what? Direct titration. Is direct titration with iodine. Titration with iodine. But here is what? Indirect titration. Indirect titration using liberated iodine. No, the iodine that is liberated from the reaction is what they use in in iodometry. Then iodine use. Iodine used. The iodine serve as titrant air. Iodine is what? Is titrant. You know titrant now? Yeah. Then the iodine here is is product of the reaction. It's not titrant. It's a product of the reaction. So what is analyte in iodimetry? The analyte in iodimetry titration is reducing agent. Reducing what? Agent. The analyte in iodometric is what? Oxidizing agent. So these are the basic difference. But let me use a table to summarize the four types of redox titration. The four types of titration types of redox titration. The second one is reagent. of the titration. The third one, indicator of the what? Of the titration. What type, the first type of titration we have? We have permanganometry. Permanganometry or permanganate titration. In permanganate titration, what is the what reagent used? The reagent used here is KMNO4. What is indicator used here? Indicator is self-indicator. Abi, what is the uses? Yes, uses. What are we using it for? We can use what? This one to determine, if you remember, the concentration of iron, oxalic acid, and hydrogen peroxide. The next one is dichromate. Dichromate titration. In dichromate titration, what is the reagent used here? We use K2Cr2O7. What is indicator? The common indicator used here is diphenyllamine. What is the color? It changed to violet. Abi now? And what are the uses here? Which use to determine the ion or concentration of ion or concentration of what? Of reducing agent. The next one is we also have iodometry. So in iodometry titration, the reagent used is sodium thiosulfate. And what is the what of indicator there? The indicator used there is starch, which form a what? Which form a blue-black complex. What are the uses of this iodometry? Copper ion, it's used to determine chlorine, it's used to determine hydrogen peroxide. The last one is iodimetry. Iodimetry. The iodimetry titration, what is the reagent used here? The reagent used here is iodide. What is the what? The indicator used here is starch. And what are we used this for? It's used to determine concentration of what? Of arsenic and sodium thiosulfate. So that is all about the redox titration. The next aspect there is what? Is just calculation. Let me solve two or more calculations there. Then I will move to the precipitate titration in my next class. Let us look at these three calculations under redox titration. I will solve 1 and 2. We help me to solve the last one and tell me the answer on the comment section. The first one here, solution. We have 25.00 cm cube of iron solution was titrated with 0.020 molar of KMNO4 and 20.00 cm cube was required. We are given this equation. Calculate the molarity. To solve that, we can say what? Mole N of KMNO4 To know the mole of KMnO what? 4 using the common formula N equal to the what? CV. So this N is number of mole, C is molar concentration, which is molarity. This formula N equal to the CV, remember I bought the formula from what we call what? The molarity equal the number of mole over volume. So this N equal to the what? CV. Please, I've explained this before in my first class in the volumetric analysis. So once we have this, what is the concentration given here? The concentration given from the question is what of KMnO4 is this. The concentration given KMnO4. So the curve it will now be what? Is 0.02 this multiplied by volume of KMnO4 given from the question. The volume of this is 20. Abi, by converting the volume 20.00 divided by what? 1000, convert it to what? To dm cube. I need to divide it by what? By 1000. So from there, the n mole, it will give us what? 0.08 mole. This is 00. No, it's a mistake. This, we cancel this, cancel each other. 2 times 2, 4. To give us what? 0.000448. Yes. Mm-hmm. 0.44 watts mole. So that's what the number of mole for potassium what? Potassium chromate. And here, since we know the number of mole, we can now say what from balancing what equation. The equation, you will observe that 1 mole of KMnO4 reacts with 5 of iron from here. 5 mole of iron reacts with 1 mole of KMn what? KMnO4. If is that the case, what is the mole of KMnO4? Now say what is 0.004 mole of KMnO4 reacts with N or X mole of iron 2 plus. So if is that the case, let me use this side for the continuation. So I will cross what? Multiply. This will come here, this will come here. You will now have what? X mole of iron 2 plus will be equal to what? 5 multiplied by 0.004 mole. So if you multiply this by each other, you will now have what? The S mole of iron 2 plus will give us what? Multiply these together. Well, it's 0.002 mole of what? Of iron. The next thing is what? We are asked to find the molarity of iron. So the molarity of iron is always what? Number of mole over volume. And what is the volume of iron given? Is what? Is 25 cm cube. Can I say what? Molarity. From the molarity. So molarity of iron, it will be what? Mole of iron over what? Volume of iron given. The volume given for the iron is what? Is 25. It will keep. We now have what? Molarity of iron is the number of mole is 0.002 over what volume given here is 25.00 divided by what? 1000. We have 0.025. So 0.025 divided by what? 0.002. So by doing that, the final answer there, the molarity of iron 2 plus, it will give us what? 0.08 mole per dm cube. Please, it's the same thing with what? With this. And the second one. So I'm here to continue from the way I stopped yesterday. If in my last class, which is yesterday, I give you 3 questions, right? 1, 2, 3. They are good example of what? Of Redox Titration calculation. So out of the 3, like I solved question what? Number 1. It remain number 2 and what? And number 3. So let me solve the 2 remaining questions before I will move to today's topic, which is what? Precipitation titration. So by solving this now, solution, we are given the volume of iron sulfate, which is what? 25 centimeter cube of iron sulfate solution was titrated with 0.020 mole per dm cube of KMnO4 solution of 22.40 cm cube of the KMnO4 was required at the end point. Calculate the conc of what? Of iron 2 solution. So we are given the asked to find the question of what? Of iron 2 solution, and then we are given the volume of what? Of we are given the volume of KMnO4 and the molar concentration of KMnO4. Abi? So we can from that we can say what? The mole of KMnO4, which is N and is equal to what? CV. Abi, by applying the what? The number of mole of KMnO4, the what? Molar concentration times volume, we have what? What is the molar concentration of KMnO4? Is what? 0.02 multiplied by what? The volume of KMnO4 is 22.4 in centimeter cube divided by what? 1000 to make it what? dm cube. So by doing that, the number of mole of K what? The N mole of KMnO4, it will now give us what? 0.00048 mole. No, 448 mole. This is what? The number of mole of what? Of KMnO4. But don't forget that what? We are looking for the what? The concentration of what? Of iron 2 ions in mole per dm cube. So the next thing is what? You can now say what? From equation. Note, in this equation, 5 mole of iron react with what? 1 mole of what? KMnO4. Abi now? So from the equation, we can now say what? 1 mole of KMnO4 reacts with 5 mole of iron 2 from this balancing equation. The next thing is what? We have this as a number of mole of what? Of KMnO4. Can I say what? 0.000448 44 what? 8 mole per what? Mole reacts with 5 what? With X mole of iron 2 ions. So here we will now cross multiply. X times 1 mole, X, 5 times what? This. You now have what? The X mole of iron 2 ion will be equal to what? This times this. 5 multiplied by 0.0048. So here multiply by 1, divide by 1 to give you this. Abi, by pressing the word, the calculator, the final answer for this, the number of mole of ions from this, it will give us what? If you press the word, the calculator, 5 times 0.0045, we have 0.00224. Yes, this is 448. 0.022 what? 224. So that will be the what? Mole. The number of mole of what? Of iron. And the question said we should find the what? The concentration, molar concentration of KMnO4 if 22.40 cm keep required during titration. So if we are looking for what? The molar concentration of this, you can now say what? Our molarity of KMnO4, of iron, sorry, will be equal to the what? To the mole of iron over what? Over volume in dm cube. What is mole? The final answer we have here, 0.00224 divided by what? What is the volume here? Volume is what? 22.40. Divide this by what? By 1000. We have 0.0224. So by pressing that, what will be the what? The final answer. Yes, sorry, there's a mistake here. The volume of iron given is what? Is this. This 24.4 is volume of KMnO4. Sorry, the iron given, the volume is what? Is 25. I'm sorry. So divide this 25 point what? 00 cm cube to what? To dm cube. We have 0.025. So if we divide this with what? With each other, at the end of the day, we are going to add up to this 0.00896 mole per dm cube. Please help me to confirm it. So with your calculator. So this is what? The molarity for question what? 2. But look at the question 3. Is almost what? The same. I believe you can solve this. We are asked to find the what? The calculate the molarity of iodide. This is the volume of iodide at 25 centimeter what? Cube. Because the iodide here serves as what? As analyte here. Abi now? It serves as what? As analyte here. The titrant here is what? Sodium thiosulfate. So we are given what? The molar concentration of sodium thiosulfate is this, and the volume required by sulfate is 30. In the same what? Procedure, use this what? This molar concentration multiplied by what? The volume here divided by 1000. The final answer you get here back to the what? This stoichiometry equation. So follow this same step I apply in the 1 and 2 to solve this third question. So I believe with these three examples, we are safe for any calculation regards to the redox titration.